Let's look at some examples for section 9.1. The first one we're looking at is it a better golf club? So Mike is an avid golfer who would like to improve his play. A friend suggests getting new clubs and lets Mike try out his 7-iron. Based on years of experience, Mike has established that the mean distance that balls travel when hit with his old 7-iron is 175 yards with a standard deviation of 15 yards. He is hoping that this new club will make his shots with a 7-iron more consistent or less variable, so he goes to the driving range and hits 50 shots with the new 7-iron. Describe the parameter of interest in this setting. So the parameter of interest is the standard deviation of the distance he hits the ball when using the new 7-iron. That's what we're looking for. So to state the hypotheses for performing a significance test, we would state H0, remember, is the statement of equality, so that would be that the standard deviation is equal to 15, so no change. The alternative hypotheses would be the standard deviation is less than 15, and we choose less than because this is what we want to show is true. We want to show the variability is less so that it's less than 15. So H sub A is standard deviation less than 15. Number 2, a better golf club. So when Mike was testing a new 7-iron, the hypotheses were what we just stated, where the standard deviation is the true standard deviation of the distances Mike hits golf balls using the new 7-iron. Based on 50 shots with the new 7-iron, the standard deviation, this is the sample standard deviation, S sub x, is 10.9 yards. So here's the problem. We want a significance test using the sample data. So a significance test using the sample data produced a p-value of 0.002. We'll worry about computing that later. We're just going to interpret it. So what does that p-value mean in this context? So the p-value means that if we assumed that H0 is true, meaning if the true standard deviation is 15 yards, then a p-value of 0.002 means that there is approximately a 0.2% chance the sample standard deviation would be what the statistic gave us, less than equal to 10.9 yards, by random chance alone. There's less than a 2% chance that that would happen if H0 were true. So do you see that, yes, that does let us reject H0, because there's such a small chance that the sample statistic would actually give us 10.9 yards if H0 were true, that the true standard deviation is 15 yards. There's such a small chance. So do the data provide convincing evidence against? Yes. Yes, since the p-value is very small, random chance does not explain why the sample was less than 15 yards. So there's convincing evidence that the true standard deviation with the new 7-iron is smaller. So once again, yes, since the p-value is very small, random chance does not explain why S sub x was less than 15 yards. So there is convincing evidence that the true standard deviation with the new 7-iron is smaller. Moving along to tasty chips. Tasty chips. Tasty chips. For his second semester project in AP Statistics, Zenon decided to investigate if students at his school prefer name brand potato chips to generic potato chips. He randomly selected 50 students and had each student try both types of chips in random order. Overall, 34 of the 50 students preferred the name brand chips. Zenon performed a significance test using the hypotheses. H0 is the statement of no change, so P equals 0.5, but you have to define what P is, and P is the true proportion of students at his school that prefer name brand chips. Okay, and then the alternative hypothesis is what you really want to try to prove is that P is greater than 0.5. In other words, more than 50% prefer name brand chips. So the resulting p-value, again, we'll talk about how to get that later, was 0.0055. So what conclusion would you make at each of the following significance levels? Okay, well, if alpha is 0.01, since the p-value is less than alpha, we reject H0 and conclude that students at Zenon School prefer name brand chips. If alpha, however, is 0.001, which is smaller, then we would say since the p-value is greater than alpha, greater than alpha, we fail to reject H0 and cannot conclude students prefer name brand chips. That's all examples for now.